Okay, so here we are going to discuss an interesting process of constructing a tangent. See, generally, if you wanted to construct a tangent, we need a center and we need a point where we need to construct a tangent. So here we are going to see the different context. What is that? When the center is not known, how to construct a tangent. Okay, so when the center of a circle is not known, how to construct a tangent at a given point. So how can we do that? Okay, so that's very interesting. Okay, this can be done with the help of a theorem. Okay, so before that I just wanted to give you a rough idea how can we do that, and later I will prove that theorem. So this is one circle. We don't know the center, but still we wanted to construct a tangent. So let us take a pointer. So this point we wanted to construct a tangent. So how to construct it? Okay, so first, this is the point of contact for tangent if you construct, but we did not construct. So from this point of contact, okay, you draw one chord into a circle. So I have drawn one chord. So let us assume this chord is AP or PA. Okay, so from where we need to construct a chord? From P. From a given point we need to construct one chord. Now if you observe here, you will get one segment here. This is the minor segment. Okay, for minor segment, what is the alternate? The major segment. Okay, so not in minor segment but in a major segment, you take a point anywhere on the major segment. Okay, you can take a point anywhere on the major segment. So let us assume that point is something called X. Okay, not X, let's take something called R. Okay, R. Okay, what is R? R is a point we are taking on the alternate segment. Okay, so here this side, if you get minor segment, we need to take a point on major segment. Okay, right. Now join this A and R, join this P and R. Okay, here we are getting some angle. Okay, let us assume this is something called 40 degrees. Okay, what is this? 40 degrees. Now come back to here. Actually we don't know the angle. So this angle, okay, assume 40 degrees for some time for understanding. After that I'll tell you the process. So this is 40 degrees. Now what we need to do is come back to here, come back to AP. At AP you draw a 40 degrees ray. What we need to draw? A 40 degrees ray. Now let us assume that 40 degrees ray will touch this. Okay, 40 degrees ray. If you join that 40 degrees, for example, let's assume it is in here. From this X and P, if you join it, okay, you are going to get a circle. Why? Because this angle and this angle are going to be equal. Okay, the angle which is formed in the alternate segment is equal to the angle which is forming between chord and tangent in the segment. Okay, the angle which is forming in the alternate segment is equal to the angle which is forming in the segment and tangent at a point of contact. Okay, so this is the theorem, and this theorem is called as what? Alternate segment. So if you know this angle, then we can construct this angle. Even you do not know an angle, you know how to copy an angle. It's very simple. Okay, do you know how to? For example, we constructed this. We don't have a protractor. Now we wanted to construct. We know that this angle and this angle is equal, but how to construct that angle? Okay, we need to copy this angle. And how to copy that angle? Okay, first take a compass and keep the pointer of a compass at here and draw an arc like this. Okay, so like this. Come back to here. okay, AP, okay, draw an arc like this. Okay, you can draw bigger or smaller you wish. Now measure, I mean adjust the compass radius to this one and come back to here and draw an arc from here. Draw an arc from here. So now join these points. Okay, so it's coming actually a little bigger. So this is arc. Okay, now adjust this one and draw an arc here. Now you draw like this. Okay, it's going to give a copy of the angle. Okay, do you know how to copy an angle? For example, here this is some angle. Now we wanted to construct the same angle here also. So how to do it? First come here and draw an arc with the same radius. Draw an arc. Now adjust the compass radius to this one. Come back to here and okay, this is not there now. Draw like this and come back to here and with that you draw it. So this is how you can construct a copy of an angle. Okay, so the copy of an angle concept, by using the copy of an angle we can construct this tangent. Okay, right, but how this is working? The reason is, okay, this theorem is called as alternate segment theorem. So what is this alternate segment theorem? Okay, this explains the relation between alternate segment angle and the angle which is forming between chord and tangent in the segment. Okay, the angle which is forming between tangent and chord in the segment, and the angle which is forming between chord in the alternate segment, those two are equal. Okay, so let us try to prove that. It's very simple and it's easy also. Okay, if you get the confidence, I mean if you understand the proof of a theorem, then you will get more confidence. Okay, see, let's try to do that. Now this is point P, so let us assume there is one tangent. Now from point of P, contact, we need to draw one chord. Okay, this is P, and in the alternate segment this is going to become segment. Now we need to prove this angle and the angle which is forming in the alternate segment, this angle, are equal. So we need to prove these two angles are equal. Let us assume for some time this is theta, so therefore we need to prove this is also theta. To prove that, okay, I am going to take the center. So don't ask, okay, why you are taking center when the center is unknown. See, already I have drawn a tangent. I wanted to prove it. Okay, to prove that theorem, how that theorem is really true. To prove that I am taking a center. Okay, so now join this O and Q, join this O and P. So that is going to be a radius of a circle. Okay, these two are going to be equal. Now this is a radius. Radius is always perpendicular to tangent. So therefore this total angle will be 90. If this total angle is 90 and this angle is theta, therefore this is going to become 90 minus theta. Then if this is 90 minus theta, then this is also going to be 90 minus theta, because it is an isosceles triangle. These two radiuses, these two are radii of a circle. Okay, so opposite angles in a equal angles, equal side, opposite angles are equal. That is a theorem, we have it in triangles. Okay, now this is 90 minus theta, this is 90 minus theta. Now we need to find this angle. Okay, because if you know this angle, you can find this angle. Okay, because this angle is, for example, if this angle is 60 degrees, this is going to be 30 degrees. If this angle is 120 degrees, then this angle is going to be 60 degrees, because the angle subtended by, okay, angle subtended by an arc, okay, this is the arc, the angle subtended by an arc at the center is double to this one, or else the angle subtended by an arc at the remaining part is equals to half of the angle which is formed in the center. Okay, if you don't want to understand the statement, you can understand like this. See, this is the arc. Okay, the arc subtended by an angle at the center, this value is double to this one, or else the arc subtended by an angle in the remaining part is half of this one. Okay, right, so angle, Okay, so this angle plus angle O, 90 minus theta plus 90 minus theta plus angle O is equals to 180 degrees, because sum of the angles in a triangle is 180 degrees. 90, 90, 180, this gets cancelled. Minus theta, minus 2 theta, minus 2 theta plus angle O is equals to 0. So angle O is equals to 2 theta. So this angle is 2 theta. If this angle is 2 theta, this must be theta. So we already know that this angle is theta. So these two are equal. So this is how we can prove it. Okay, thank you.